Hey, welcome back to Math with Patrick. Today is July 15th, and we're solving problem number 196 from the Daily Epsilon calendar. And we need to show why this angle x right here in blue is equal to 15 degrees. So I'm noticing we have what I'm assuming is a square, and what I'm assuming is the diagonal of the square that extends further. So I'm guessing that this is going to be like a straight line right here. It says that AB. Oh, do you hear that? That's Quill. He's meowing at me. Oh my goodness. I'm guessing that AB, that red diagonal in the middle of the square, is going to be equal to CD, which is this red diagonal over here. And this is enough information to somehow figure out what X is right here. Well, my first thought is that I have a lot of triangles going on. Like I have this right isosceles triangle right here. So these are both 45-degree angles. This is a 90. I also have this kind of large triangle right here, triangle ACD. And so its angles are going to be 45, and then C is going to be 90 plus X. And then D, I'm not quite sure yet, so I'll just call it D for now. And I'll say that this is angle D. And then I also have this small triangle right here, and maybe learning about its angles will help out too. It has an angle of X, clearly that's this one right here. It also has an angle of D, and then this one right here, I believe it's going to be 90 plus 45, right? Because the 45 is there because this diagonal kind of extends downward. And then we have a right angle above it. So overall, that's going to be a 135. Okay. I know that if I add all of the angles of a triangle, we should get 180 degrees. So I could kind of put these plus signs here. We get 180, we get 180. And actually, interestingly, both of these equations are the same. If we just kind of add these two numbers together, we get this. So maybe we could get x plus d is equal to 180 minus 135, which is 45. So that's kind of cool, I guess. Now we have some kind of relationship about x and d, that they're both equal to 45. I was really hoping that writing two equations and two unknowns would like get me a solution, but it turns out both equations are just the same. So I have to look elsewhere for some information about x or d. If I like draw maybe like an extra line right here, I'm trying to do something with parallel lines and a transversal. Maybe that's going to help. Where here I know that angle x is going to be an alternate interior angle to this one right here. And x plus d is, oh, that's another 45 degrees, right? Because like I'm kind of seeing how this diagonal continues. This angle right here should be 45, kind of like how this angle right here is 45. And so I've once again proven the exact same thing, that x plus d is 45. But that doesn't like tell me more information about x or d. I haven't really used this like long line right here, and let's just assume that the square is like a unit square. So that way I can label these like red sides as like root 2. I could draw the other diagonal of the square. That would be another root 2. Oh, there it is. And if I draw another line from here to here, just based on symmetry, this should be the exact same as line segment CD. So this is another root 2. So in our diagram, I actually didn't need all of these ones. In fact, I didn't even need to make any measurements really of the side lengths here. We have an equilateral triangle that's hiding in here in the diagram, and that means this angle right here is 60 degrees because an equilateral triangle has 60s in all spots. So looks like based on symmetry, that means angle D is 30 degrees, and that must mean x is 15. Cool. Well, there it is. Yeah, x is 15. That makes sense. And I think that also makes sense over here because, again, equilateral triangle, if we have 60 degrees all the way across and we take out the 45, we're left with just 15 degrees. Cool. Well, that was a fun problem. Guess we're all done. I enjoyed solving it with you, and I'll see you tomorrow. Bye.